Good. So after this week, we only have 2 weeks left. 2 weeks left. So very happy. I hope. I guess everyone are busy with your final projects and exam preparation, same as I do. I also preparing a lot of stuff for you to have fun at the end of the semester. So luckily we're done with ANOVA already. So only 3 classes left will be focused on regression. So just to remind you that we have class on 17 and 20. We'll finish everything, and then we also have a 24. We'll do review and also go over the past year papers. And then 27 we don't have class, but we have class at the end of the day. So I know it's already exam day, so I don't want to ask you to come, but and also remind you that our TA will offer a tutorial on 20th. Okay? I think it's already in the on the announcement page telling you that at the Thursday night next week, not today, next week, the YIA will be there, and then I think there will be Zoom would be also available as well. I think they don't have Zoom directly, but there's Zoom record, so you can attend, and if you see the record as well. And again, you are welcome to talk to the TA beside the tutorial. So here comes to the very last chapter, but before we do, let's very quickly review what we have done in ANOVA, because that will set the stage. And as ANOVA will be a very special case of regression. Okay. What is analyze variance? As you can see, is ANOVA, right? It's ANOVA, ANOVA, analyze of variance. And if you recall, this is a special case or general case of a 2-sample t-test of same variance when extended to more than one group, right? A 2-sample t-test of equal variance. We're asking whether the mean the same, but now we are having more group, asking all the mean are the same or not. Okay. And this is pretty useful idea, right? So the way to test if you are more than one group is to use a variance idea. If you still recall, let me quickly review this particular example, the graph, right? You can estimate variance in 2 ways, at least, actually 3 ways, but we've compared 2 of them. Because if they're in the same location, if you measure variance within group, which is SSW, right? So you calculate that the variance for each group, okay? And that come up with the variance, okay? And you also can estimate the variance by comparing variation between group mean, right? For each group, you have the sample mean, right? The variation of sample mean is the SSG, okay? If there's no difference between x1 bar and x2 bar, x3 bar, these 2 variants should be the same, right? Because they're different way to measure variance. But if they actually locate in different direction, this SW and SSG, if you measure the variance, they will be very different. Okay, and that's why, and you can see that by construction, the variance of the SSG, right, between group, right, will be larger than within, right? If there's a difference, this G will include not just the variance, but also the distance between them. So that's why it's a 1-tail test, not a 2-tail. Okay? So that's why you would see we do the right-tail test, because this guy is more than this guy. Okay. And the most important part is not look at the table, because table is only limited number, right? And you would be using this we cover in the case, right? Maybe I look at Excel now, okay, and show you that how you can operate that in the Excel. I think we covered that last time already, right? After this time. So basically, it's just like the important point is looking at this p-value. Okay, if this p-value is less than 5%, that means that this grouping do have some meaning. Okay, not the same. So after that, then the next step you want to do, maybe you would want to do a t-test accordingly and see which one is different from others, right? So if f-test doesn't pass, then you don't have to go through the second step. So f-test probably you can consider a screening exercise to see at once are all the same or not, right? Once you do that, then you can go on and do the t-test, right? And see which one is particularly more different from the others. Okay, so that would be the idea I think we talk about, but we don't do the two-way ANOVA. Okay, and what I mentioned about two-way ANOVA is the observation you have more than one grouping, right? One-way ANOVA is like every observation is either say G1, G2, G3, maybe different cities, right? G1 maybe Hong Kong, G2 maybe Shenzhen, G3 maybe Guangzhou or Macau, right? So you would have different things, but if you have two-way ANOVA, the data looks like this: is maybe A1, A2 a city, and B1, B2 a gender, right? So each observation will be characterized by two things. One is which city, and also whether female or male. But the two-way ANOVA, I don't think we have time to cover, so I just skip from that. And also, I don't think people use this particular two-way ANOVA in practice, because this one have to restrict to the same number of observation for each group. Okay, but regression you don't have this restriction, so I don't see. Actually, I don't really see people using this. I mean, one-way ANOVA still people use it because not very restrictive, but two-way ANOVA is like too strong to say things, because remember you need all the observation in all the cells equal. But if one cell have very little number, then you have some issue there. So unbalanced, but of course there's some way to handle it. But if there's some way to handle it, why we learn some way specific? You can just run regression. I mean, if you learn the next class 2021, actually you learn regression can easily handle this kind of problem without a big issue. So that's why I don't want to cover this something not very useful. So of course, at the end of the semester, if we still have time, we'll go over that. Okay. But at the meantime, I want to focus on something, as I said, the most useful thing in this class, and also this is something that you would learn more if you go further in statistics. Okay. It's called regression. The first time you learn this name is why we learn to regression. Why shouldn't we learn progress, right? Why we learn regress, right? Progress means improvement. Regress means you go back to the day that you haven't improved yet, right? It's like Back to the Future. I don't know whether you know the movie, right? Why you want to back to the past, right? So so this is the case where, as I mentioned in the ANOVA, you study each observation you have grouping, but the group are categorical in ANOVA. So each group has no meaning by itself. Okay, but very often the grouping would be meaningful, and very often the grouping actually is something measurable. Okay, and ANOVA we want to investigate whether grouping would make a difference about observation, right? We want to see whether different city with different ways to pay for a product, right? But very often actually we are able to quantify the grouping. Like instead of looking at whether you go to college will make an income difference, you want to see how many years of education make a difference. Okay, and very often in marketing you want to see advertising, how much you spend affect your sales, not just the channel, which is discrete, right? You may consider online advertising, offline advertising, and sales, right? That's you can doing in ANOVA. But if you generalize looking about advertising expense, which is a continuous variable, a numerical variable with sales, then you need a regression. Or the case in medical usage, you want to test a new drug and see how the drug's dosage and the recovery time. And these are, want to study the relationship between two continuous random variable, or even discrete is also okay, two numerical variable, then you will use regression. Okay. And this is extended ANOVA because ANOVA is talking about grouping, right? Nominal thing, you can say education and income. Of course, you can do high school, college graduate, master degree, right? 3 groups, and you see different thing, okay? But the thing is, when you do this, you drop the idea that, right, you spend actually more time in each category, right? So undergrad spend more time in school than high school, and master spend more in undergrad, right? So it's better you use this information. And that's why instead of nominal variable, we consider numerical variable, right? How many years you do. And to do it, we want regression. Okay. And actually regression can also go back to ANOVA. So to study grouping. So that means that regression is the most flexible tools. And that's why you will see in most of the advanced study in statistics, everyone is basically using the regression, because regression is the thing that is the most general. Okay, and do note that in our class we are talking about correlation in terms of regression. We don't talk about causality. Okay, it doesn't say y and x, which x cause y and y cause x, because you just name what you want, right? It doesn't have to establish. But if you want to actually say x cause y, you need to know why it changes. Okay, in very often in the science or in business experiment called A/B testing, is you make a difference. You decide who receive A treatment, with receive B treatment, right? And this is going to be random. Or in the medical exam, so medical drug test, is you would randomly assign patient who get the treatment and randomly assign who get the placebo. That's a random. And in that case, once you control who get what, and the result you would get, the correlation will have causality in it. But just regression don't establish causality. You have to have more knowledge to say causality can be coming from correlation. And to do it actually require usually a master level course. Okay, usually undergrad we don't cover that. Okay? That would be something master level and actually PhD level, and you will be surprised actually you require a PhD to establish causality. And a lot of people actually would, I mean, many economists actually make a living by doing this, and many say big internet company like Meituan, Amazon, Alibaba, they all do this kind of A/B testing, and that's require a lot of things to check. And that's one of the job of a statistician is going to do causality. I mean, so of course, this regression is very powerful. So we just learned something we call simple linear regression. So by simple, it means that we only do X and Y. There's no Z, there's no other more. But if you go to the next semester, if you do 2021, there will be Y, X1, X2, up to Xk, there are many. And here, of course, on linear, which means that we are focusing on drawing a line. Okay. And in general, can be any polynomial, can be any curve, can be anything. Okay. So we just focus on what we call simple linear regression to make our life easy. And then you can imagine actually 2021 actually spend the whole semester and doing different type of regression. So the whole semester is doing one regression. I mean, of course, there are different types, but regression is the main goal of learning that class. So if you want to learn more, that would be the goal. But I assume most of you have enough of numbers and math. So probably this is the last class for the rest of your life, unless you go to master degree, which you will do this all again if you do any business master degree. I mean, you will do this again, unless you do something art or with or something unrelated to anything quantitative. Otherwise, you will face this kind of problem again, because regression is a standard tool. If you want to accept, you make use of data. Okay, there's no, I can't think of other way around you are not using. Okay, even everyday use LLM is behind is still a regression. Okay, of course, a different type, but regression is the key. So the difference from the previous chapter is before the data is you have X1 and G1, right? But now it's a continuous random variable, so that's why you will have X1, Y1, okay, for the first observation, and then Xn, Yn with second observations, okay? And the objective of simple linear regression is actually very simple, okay? You can do this in scatter plot, right? This is something you do in the topic 1. Now, as we have hinted, regression is simply find a line. That's why it's called linear regression. And simple means only have 2 dimensions, right? So they basically just X and Y, right? Just a bunch of point here, right? The ideas, right? Bunch of point here, right? Bunch of point here. Okay. And the goal is to find a line to represent this data. Okay. So don't underestimate the idea of a line. There are 2 things here. One is the line, the point only have a finite number of data points. And the line is infinite number of points. So you're extending your knowledge from a finite number of sample to actually infinite number of line. So that's one thing, okay? So extend your knowledge from the data to the situation you don't have data, right? So that is the first thing. Second is actually what we call dimension reduction. Before you do it, the model is very complicated, right? The thing you have is many data points. You don't have any idea what's going on. But once you collapse into a line, basically the knowledge about X and Y is no longer n data point. Rather, it's just intercept and the slope, right? In your high school math, you know, when you fit this equation, A is the intercept, B the slope, right? Slope is how much X increase, we increase Y, okay? So basically you're collapsing the data into only 2 numbers, A and B, okay? So that's a twofold of the idea. Okay, let me repeat because they're so important. I want to make sure that you see what I'm saying. We start with a data set can be represented by a scatter plot, okay? Which is, if you have many data points, that can be very complicated, okay? But no matter how many data point there, it's not a complete picture of X and Y. When you draw a line there, you're actually telling that when you have no data, what it is, okay? And when outside the range, you also do it, okay? So it's just infinite number of points there, okay? First. Second is that many points can be very complicated, but now you're collapsing it to from n data set, data point, to only 2 numbers, okay? So it's dimension reduction, okay? So that is a very important to, instead of having a data with a model, so regression is building a model, okay? And simple linear, as I said, simple means you only have 2 variables. Use simple means use X to explain Y. And linear, because if a linear, okay, you don't have a square term. Okay. So in the next class, in the not next class, next course, if you ever take, actually can go to say square C, something like that. And also so on and so forth. Need not be X, can be like D of Z, so on and so forth, but that would be not in my class. Okay. So you will call this regress Y on X. Okay. So there's a terminology. Okay. Or Y is regress on X. So that's a way that people say it. Okay. So we call how you write the line. We use the slope intercept form. So A is the y-intercept, we've shown you already, and then B is slope, right? A is the meaning that when x is 0, what is y, right? So just to recall, when you draw a line there, this is x, this is y, and this is A here, and the line passes within this way, and the slope is B. What the slope means is if you increase x by 1, how much B increase? Okay, so just make sure that you remember this, what we call the slope-intercept form. If you forget, just check back your high school course material, that will be there. Of course, if you don't, Wikipedia with or any Google or any AI will be your friend to explain to you as well. But so that will be what we call the simple linear regression, as the data show you, right? In the we have learned in the topic 1 that one way to quantify that is called correlation or covariance, right? And actually you will see they're closely related to the A and B you're going to find. Okay. But before that, simple linear regression is just try to draw a line. Okay. The question is probably which line to be drawn, because if you don't have a criteria, right, any line will work, right? Which is to be the line? Okay, what's the line? Okay, what's the line? And the criteria, which is I think is first proposed by the famous mathematician Gauss, is to minimize the sum of the vertical distance. Okay, the distance, distance there, you square it. Okay, you want to minimize this vertical sum of the distance. Okay, sum of the square the vertical distance. Okay, why you want to do that? Okay, and that is actually y square actually coming from the idea the variance, because square you forget about negative positive. That is simple. Okay, and square because of the math is much nicer. Because we learn same as variance, square actually the math is nice, is smooth. Okay, and you ask why I want to minimize the vertical. All right, it's highly possible that I can have the horizontal distance. Right, why I want to care about the vertical distance? Okay, the reason is being that we're trying to use x to explain y. Okay, the idea is use x to explain y. Okay, and that means that this, given our x, this is my y, and this distance is the mistake or error, right? So we want to minimize this mistake, right? Because we want to use x to explain y. So this is the error. Okay, so we want to minimize the vertical instead of the horizontal. Okay, so let's talk about the math. Okay, your data is x1 to xn. Okay, your line is a plus b x. Okay, and the line we call the head. Okay, data has no head. Okay, because head is the estimate. Okay, and vertical distance is defined as the yi minus yi head, or reverse, doesn't really matter. Okay, you can use y head minus yi, but traditionally you just take in this way. Okay, so just the distance d, right? So just to remind you what it is, right? So this is x, this is y, and if this is your y head, right, is a plus b xi. Okay, and pick a data point here. Data point is this data point is xi yi. Okay, and this is what this point is xi yi head, right? And the vertical distance, this distance, right, is di, right? It's yi minus yi head. Okay, and what you're going to do is sum of the vertical square difference, so it's sum of all the di square. Okay, so as I said, y square, square is to, later you see, do the math, it's more simple because we can apply calculus, although we don't do calculus, but this is the way things being derived. Okay. And this is this D is equal to this part. Okay. So you put yi hat is this formula, you put it back. This is what you want. Okay. So the idea is you just choose A and B to maximize, to minimize this D, right? That means that changing A means you move up and down parallel, right? Basically, just changing A means that these are all the data point here. Okay. You're changing A means that you are going to have a many parallel lines, right? And this is changing A, right? This, if you increase A, you go up parallel, you decrease A, go parallel. And you also can increase, keeping A the fixed, you can say increase B or decrease B, right? So basically you are changing the intercept and the slope such that the sum of the distance squared vertically is all the minimized. Okay, so this is called the least square method, invented by Gauss. I think that he made himself famous by looking at the sky, and I think in the 1700s, people are tracking the comet on the sky, a shooting star. Okay, and at some point it disappeared from people's observation, and people try to calculate where he is. I mean, flying. And Gauss, the famous mathematician, actually used this method to track, to predict when the new star would come back and when and where. And he used this method and he did it very successfully. That's why he get him very famous. Okay, so this is the first case people lose least square. And so far you see in this model, only math. There's no statistics because that is not invented at that time very nicely. You can do it. We will talk about some statistics later, but at this moment, there's no statistics, only math. Okay? So this least square is just something the kindergarten kid would be able to do, right? You ask your cousin, right, or your younger siblings, give them the point, tell them what's the meaning of the best line, then they can figure out what is the best. Okay. And I'm not going to bother you with the math, but this is what to mean by minimize the distance. So minimize the vertical distance. Okay. And this explained already why I want to do that, right? And sometimes if you don't want to minimize the vertical or horizontal distance, there's something we call perpendicular distance, right? Then that's called orthogonal distance regression. So something like the point here, you draw a line there, you want to minimize the this distance. Okay, but that would be something that are really, there's some uses of this, but not our concern at the moment. Okay, and sometimes if you don't want to do square, you want to do absolute value, then the name called median regression, or what we call the least absolute deviation regression. But I don't think we care too much about this. But just let you know, there are many things as well. But we focus on the thing that most people would do. Okay. So don't want to bother with math. Immediately give you the result, right? Because you would be wondering, what do we have? Okay. What is the best A and best B here? Okay. So best B here, something like very crazy. What's this guy? Okay. If you see this guy, should remind you this is the numerator of covariance. Okay. And this guy should remind you variance. So if you divide this by n or n minus 1, depending on what you like, you should get covariance and variance. Okay. So turn out that the slope of the line that best fit is the covariance of xy over variance of x. Okay. And that is actually very close to correlation coefficient, right? If you see, right? If you divide it by standard deviation of x and then y, it actually is a correlation coefficient, right? So that's closely related. Okay. And that means that if variance of x is 1 and variance of y is 1, then B is simply correlation coefficient. Right? But anyway, so this is the formula. How do you prove that? I'm not going to do it. The slide is already there. Okay, that's proof inside, because if I do it, it's very boring and no one will listen anyway. Right? So, but if you want to know, it's simply a multivariate calculus. Okay, but just take it as given. But one thing is, this is not something too much interesting. But one thing interesting from this equation, what do you see? A, the intercept is equal to y bar minus bx bar. What does that mean? Let's rewrite this. You can rewrite as y bar will equal to what? A plus bx bar. What do you get? You will see, it means that the best fit line will pass through x bar, y bar. Right? That means that x, y bar is on the line. That means that the regression line will pass through what we call the center of data. Okay? Center. Okay? Okay. So this is the first observation. The second observation, we know that you can see the B only depends on x minus x bar, y minus y bar, x minus x bar, right? So if you subtract the mean from the data, you run the regression, actually has no difference. Okay, the B will the same. Okay. So actually that would give you the idea that what B is. B is, give the idea, the regression is explaining the y vary deviation from the mean by how x deviates from the mean. Okay, let me repeat. This is very important. What is regression doing is to explain the variation of the y from the mean using the deviation of x from its own mean. Okay, well, I will be more specific using the graph, and that is the meaning of this. Okay, let me go to the picture again. Okay, so this is what I said when the regression line passing through the center of the data. Okay, the data is green. What is x here? X is the x bar is the mean of x. What's mean of x? Just to recall, what's mean? Mean is look at all the distance from the left, same as distance from the right. So that means that this distance add up should be same as distance add up. Okay, it's in the middle. Okay, same for the y. Okay, y will be look at this distance from below. Okay, should be same as from above. Okay. Okay. So this is standard data. Okay. So that means that if I have x bar, I would expect y bar, right? So if your data is not x bar, say this one. Okay, so this is x. What are you predicting? You're predicting here. Why? So this deviation from the mean, and you explain this deviation y is here, right? You explain y different from y bar because x is different from is x bar. Okay, you explain the deviation of y by deviation of x from its own mean. Okay, why is important? Because try to build a relation between x and y, and you want to use x to explain y. Okay, and the fact that if I don't give you x, what is your prediction of y? So if I don't tell x, say x may be your education, y is your income. Okay, if I don't tell you that guy what is his education background, what is the guess of his income level? Simple, average, right? Without anything, right? But if I tell you that he is the guy who did a master degree, right? Maybe somewhere here, right? Then you would revise upward, right? If I tell you this guy only have high school degree, then you will revise downward, right? So that means that your prediction or explanation or what you've guessed the y is changes because of x changes, right? Otherwise, you just the best guess will just y bar. Okay, and how much you change is the slope b, right? So that's why I said, right? B is trying to give you the idea how much x is different from its mean. That is give you how y is different from its own mean, y bar. Okay, so that's the meaning of regression. Okay, because of you can always use y bar as your predictor, as an estimator, right? But now you use x to help you to do explanation prediction. Okay, then it must be because of x is different from its own mean, right? And that would lead you to say y also different from its own mean. Okay, otherwise it should be same as the mean. Okay. Now, once with that, okay, you will not be surprised to see the idea here, right? The b, the denominator is always positive because square. Adding square of sum of all the square are also positive. So the numerator can be positive, can be negative, right? Depend on covariance, right? If covariance positive, b is positive. Covariance negative, b is negative. Okay. So that means here, if positive slope the line, okay, actually come from covariance positive, right? Remember, covariance positive is this value times this value, right? Positive. This value times this value positive. So this is something that you learned before, right? And when covariance 0, b is 0, right? Then the best guess is a horizontal line, because remember what's covariance 0 means that they're unrelated. If they're unrelated, then you shouldn't use x to help you predict y. The best guess is just y bar. So the y hat will be same as y bar, right? Exactly. So that would be the idea. And if your covariance negative, of course, your b will negative, right? Because they're negative related. So that's when everything is very natural. Okay. And now, to further give you the idea why this formula is right, look at this denominator, which is variance, right? Because you can divide both by n, right? So let me explain why if you increase variance, b will decrease. Okay, holding other thing constant. Okay, so look at the data set from the red one, so the red dot, right? And the red dot, you draw the regression, looks like this, right? And the blue dots are here, and you draw a regression line, will be something like this. Okay, so the slope increase. Okay, but you can see why we call variance increase, because of x, the red and the blue have the same center, right? And only the blue one are more further away. Okay, so they have same mean, but much larger variance for the blue one. Okay, so increase your variance will spread this out. Is that okay? And next is, you look at this formula here. Okay. If you double x, okay, numerator double. If you double x, your numerator quadruple, right? Because square. Okay, so that means that you double x, you double the numerator, quadruple the denominator, which means that your b will be 1/2. Okay, and let's see why is the case. Okay, look at the case of red. Okay, X and Y. If you double the X, you keep this data will change to here. This data move to here, right? Because you same Y, but you double X, everything double. And that means that your B will half because everything double. Okay. So that's why you make your X bigger, your B will be half, right? You double the B, double the X, you double the B. You half the B, you double the X. Okay. So that explains this. Okay. And what happened if every Y increased by 1, X keep the same, so just go up, right? And you will see A go up by 1. Why? Look at this equation. Every Y go up by 1, this remain unchanged, right? Because everything go up by 1, mean go by 1 as well. So this B remain the same. And for A, B unchanged, X unchanged. Every Y go by 1, this Y bar go by 1. Okay. So that means that A go by 1. So that is what it means. Is that okay? Okay. So let me go into this example. Okay. We have data 4, 7, 6, 4, 9, and 1, 2, 3, 4, 5. Okay. And how to calculate the slope and the intercept. Okay. So we do it using this table, okay, that you construct. So this is all the Y and this all the X. And first, we can calculate the mean of X and mean of the Y. Mean of X is 3. Mean of Y is 6. Okay. And for this column, you just subtract everything from X bar minus 3. So you get all this number minus 3. Okay. And the next is this column, you minus everything from 6. 4 minus 6 is 2, and so on and so forth. Okay. And the next step is multiply these two column, you get all this number, right? And why we do that? Because this is the numerator of the B once you add up. And you also multiply this by itself. Why do that? This is the denominator of the B. Okay. So this is the numerator, adding up all this, becomes 7. And you add up all this number, give you 10. And the B's are just this divided by this guy, which is 0.7. Okay. And the A will be just Y bar minus BX bar, give you 3.9. Okay. I guess at 1 minute, I can talk about Excel real quickly. So I just tell you that how to calculate this. Let me just use Excel in, let me, please give me a few more minutes. I will just show you how to do Excel. So you have Y and X, okay? You have 4, 7, 6, 4, 9 here, and 1, 2, 3, 4, 5, okay? The question would be, okay, can we get the slope and the intercept quickly, okay? Slope and intercept. The answer is yes. There's a function actually called slope. Slope, and you tell them what is a Y and what's your X, then you're done. Okay, so this is the formula. Okay, you just tell them A2 to A6 is your Y, and tell them what's X, then you're done. Intercept is just the same. Intercept A2 to A6 and B2 to B6, then you're done. Okay. So this is the very quick way to do the slope intercept. Okay. Then very quickly, you know now, no matter how long the data is, okay, you can collapse this to these 2 points, right? Because remember how important it is. You make the data so complicated into 2 numbers only. Okay, and this will apply to every number you input, right? Every X you want to put in, you get the Y. Okay, so that's a much more simple and much more general. So I guess I overrun 2 minutes, so we'll give you 2 more minutes for the break. I know you guys are super tired, so that's a break, and we come back at 2:30, 32. No, yeah, 3 minutes, so 33. Cool. That's a break of 15 minutes. Oh, this is the main groups. You are over it, well, I think it's there. And figure out that. Okay, some of them. Table line. As you say, the something. They're different. Not all the ones. Those are over there. Those very many and unchecked. So that of course there's a problem. The 2 group very good how many one. So because it's always every currently take out the they say the same. Because we know that always every how they define this. Think about that, only one balance. We didn't know that for all the things. So that's fine because yeah, how pretty that's right. Why so just one thing. Once we check the that's 5. Right, so how to there's some effort, that's the level. You can definitely do this. I do less problem. Oh yeah, only data stuff. Actually, that case file or something. All the text doesn't. Not small. Yeah, that's really if you go to explore but you know fast. One day. It's so in how well how checking the how good the how well your client is. Yeah. How good the manage is done. How the apply the apply rights correct. I don't care. The values to use some rest of those things. So the V because some data right, people would probably pay. So even go to probably they got paid. They will collect some data just so we go with many size studies except for that. And so our agency very popular science. It's not about statistics, it's about don't kind of go over it's not dependent on you. Models these. There's a question asking the right no, of course, you don't have to have this standards. Usually it's simple enough. But if I think the model result is too unbelievable enough as how I would it help. But in general, I mean occasionally I think about serious about see teachers of everything. They know I take it basically. I don't check whether you should not. It's too good to be true. Random. Sorry, but it's too perfect. Very nice. The piece so small. And it's very small. That's the answer subject thing. The piece by so thing. Must be something. Otherwise. I mean, only you can do project you do not buy it, but they all think like go 100%.
Yeah, it's an exercise and use this implement to just to say, oh, how would you know this?
Like application. Right, but you do have some sample projects and just basically follow.
But where is
Yeah, because everyone is following like everyone follow, right? This is something that plays. When we ask the right question, should we not? Phrase the right way, right? Right.
There are some shots where I'm like really, but it was grown up as maybe true. But there's another experience with your face was like physical. So do you know that?
I don't know.
But
Yeah, that's pretty long.
Hey, this is you.
Oh, it is.
Do you know this?
Oh, yeah.
She made what it's.
Oh, it's Tuesday.
And then.
Wow. Let's meet you in 1 second now. Okay. Okay, I need to play here. Yes.
I wish. Oh, each. And then there's just like.
Yeah, it's a
Oh, it's
like
like, oh.
they join is like. So that's why it's all.
Oh, that's what it's all.
All online, so I played before. I know the Zoom doesn't, but I do the some of the student.
That's fair. If you want to just record, just.
Always doing so often.
Yeah.
You guys see it, it's not.
But everything's.
What is it, it's the, this, you see the way I explain it, but how I explain it. But
Did you feel like you explained the.
I understand. The old days is a little bit. The old days I more technical. Now I think more business. So you look at my class at that time, so I said, how often is done? But if you come back any later, it's not going to do me different. I'm transforming myself. That is not in the. You were not there. Now, so business. What we can do in review, right? Is proven people are okay, you understand this part by part. You having style, how to explain it. Now after for many years, no one came out, no one asked more because more or less native. And with your question on the one,
Yeah.
so that's yeah, that's why that's how you perfectly believe it. You would possibly for that it's
Wait, really?
yeah, that's okay. But I don't know that. So almost as old. I can't be almost cross. Something I know.
How many people read?
I have people to. Except allowing. Not very easy. So it's not. I'm more than B.B.A, so I'm going to die, but that was. But so you go by 5%. I'm so. Yeah, just. Okay, so all these. But research, explore or something. I don't need not. It's not usually teach you. Other people, it's for them. That's why I don't like John. That is all of us can be very much frustration, but frustrating. Solve the problem. And he's there to come on. But even doing that sort of. So I don't know, really a lot of things not. I think this would I thought these were brand school science. How to say share problems. I can't really see exactly where we how to allocate money. I only know you were your two probably second. But I don't know exactly on the problems. I only know the other person. How the first part 7 I think if I know you how to watch and if you got text, like how to do things like that. Okay, for the shares and stuff. Like that. So it's also. Okay. No, the point is great. Don't be assignments, assignment exam person always have a student. I would think. I don't understand. But I don't want this far. I don't know. Almost like things. I don't make it out. Because this is fine. But they do it very back. It out there. Or some stuff. But I don't think so much. And I told you right. So I hope everything is nice. Let me restart the screen because the screen is not showing anything. Yes, that's good. So let's see how well you're doing. How many assignments in total? I think the assignment have been all released already, so there's no additional assignment except the optional assignment as a no friend regression. I will upload that later, but that assignment doesn't count at all. So assignment 4 is your last assignment. No, yeah, assignment 4 is the last assignment. Assignment 5 is optional, so I will release the answer and question. I'll release the question, and after a few days, I will release the answer. So that's only 4 assignments. Okay, I don't think we are. Actually, we don't have. I don't think we have much higher workload than others. Okay, I think it's comparable, for all the section across. And that's good. Just a gentle reminder that I mean, especially before your exam, you want to do a self-checking quiz. It's here, but I have a 5, 6, 7, 8. Will be released after the weekend. I think our TH checking everything is all right. But just to remind you, this quiz, just do it because do it, you get a credit. Okay, we don't care about how well you're doing it. Okay, just if you take the time to do it. Okay. Next, yeah, least square method regression. That's good. So regression is to find correlation. Almost close to correlation, but regression is finding a line. Okay, and the line is closer with the correlation. But do remember that regression is not correlation, but regression is try to explain, build a model which a line to how A, X, and Y related. And correlation is closely related to that, but it's not exactly correlation. Okay, correlation is just a number, right? Because it is a non-model, right? Just a number to represent how they're related. Okay, but regression telling you that way more than that, because you give me the X, I'll tell what's the Y hat, right? by multiplying by B plus A. So it's a way much more complicated than correlation, right? Way more different, very different from that. And overall it's okay. The speed is fine. And most of you can follow. I hope that's okay. And okay, that's better because we saw not more than 50%. It's too tight, but adding up is still 70%. So I think we know, as I predict at the beginning of our course, right? Beginning is like here, somewhere here, somewhere here, somewhere here. And probably I ask next week something like this, right? Or even everything is here. I do understand that is something that you're getting more tired. Especially this class, after if you have many carbohydrates, you will feel very sleepy. So that's why I've told you I try not to eat anything in the lunch. So to make sure that I don't have carbohydrate. But of course, keep something in your stomach. I mean, some fiber. Otherwise, yeah, not good for your stomach. About our finals, okay? Since you learn statistics, you should learn one thing in our estimator class. What is unbiased estimator? What's the best estimator? Right? You are doing prediction, right? You predict what is in exam, right? Right? That's what you're doing, right? When you do revision, of course, you understand the material, but you want to do good, you estimate what is in the exam. What's the best estimator? Last year paper, right? I give you already, right? So you know what to guess, right? That's unbiased estimator. And also, exam also reflect what I think what is more important or what should be answered, right? And there's the first guess. What is the second best guess beside past paper? Yeah, your assignment. So go for your assignment. Check whether that's okay. Okay. What's the third one? Self-checking quiz. Yes, that's true. What's the fourth one you guys should go? The green boxes, the examples. Okay. And once you're done, then basically you are done. Of course, the fifth, which is actually the most important, but not important for exam, is look at the purple or blue box. Look what is actually the formula, what the meaning are they, but that is the final one. But you will go for the past paper. We will do the past paper on the I guess 24th or 36th. Okay. Unless our TA take the job from me. If TA take the job from me, then I would do something else. But let me know if the TA cover something he shouldn't cover. But if he cover that, then I will probably put another past paper to do that. But you will see the two past paper are very similar. So if you ask a previous cohort, if you're able to get the 2 years ago, very similar. And 3 years ago, also very similar. So that's I get is a very good guess of what might be there. Okay. So I have something we want me to see the thread. So let's see. Let me copy everything so that I can check here easily. Let's see. What do we have for the thread? So hopefully make you not so tired. Hopefully it's fun. Oh, gay parking only. Oh, I have it.
It's my car, yeah.
Oh, it is? Okay. Are you gay by chance?
Am I what?
Are you gay?
No, I'm not.
Because you parked in the right there. I don't know if you saw in the gay parking only.
Oh my God, I never noticed that.
You didn't see it when you pulled in?
No.
Yeah, because it's gonna be
So what am I gonna be fined for this?
I mean, unless you just tell me you're
Why can't
gay.
I move?
Because you've been parked here already, sir. Unless you just tell me and I'll just scratch it.
I'm gay.
Oh, you are gay? Okay. All right, perfect. So I'm gonna have to ask you just like 3 simple questions so that I could prove that you're actually gay. Just real quick. On a scale 1 through 10, how gay are you? 1 through 10.
1.
1? Oh, that's not gay enough. Maybe like 9.
Okay.
Okay, you are 9. Okay, perfect. And then second question here, could you give me your best gay voice to prove that you're actually gay? Okay, perfect. And the next question here is, how many men have you slept with?
7.
7 men? Holy, you were really gay then, huh? Oh, okay, that's all, sir. You're good to go.
Are you mean to tell me that there are certain parking just for gay people?
Yeah, it's part of the LGBTQ community. It's a new thing of San Francisco. Just to make sure to look out for those, all right?
Okay, that's the
Hello,
beginning.
sir.
Yeah.
Oh, is this your vehicle right here?
This vehicle right here,
Yeah, is it yours?
my car, yeah.
Oh, it is? Okay.
Okay, it's good.
Are you
You're
gay?
hacking happier. Okay. It's fun. I hope you enjoy that. Now let's continue our journey. Okay. Which is our regression. We know how to do the slope, do the intercept, and I showed the Excel function, so we don't have to worry too much about the calculation. But if you do, that will be just a bunch of calculation based on Excel spreadsheet. You can actually do it quickly, right? And this is a proof. I guess I don't want to bother with the math, but let's go to this one. Okay. This is something actually we call the later you will see this called the Gauss-Markov theorem. Okay. It's trying to say that the formula we have here, this formula, A and B, have the nice property. What do you mean by that? Okay. We will consider a statistical model such as A and B are good estimator. Okay. But before we do that, we have to introduce a model. Otherwise, there's no statistics. Then how can we talk about estimate? So we start with the model. How X are Y related? First, we have to assume that Y is related to X linearly by some number alpha and beta we want to know. Okay. And epsilon, it's something that we cannot control. It's a random. Okay, it's a random thing. It's called error. Okay. So that means that in this is what usually we call data generating process. Is how the data getting generated. Is you have some X, you multiply by beta plus some alpha, and have something we can't observe, some noises. Okay, and that's why you observe. Okay, if without noises, then X and YI are basically perfectly aligned. Okay, a perfect line with intercept alpha and the slope beta. But because of the alpha, so because of the epsilon, that's why you're supposed to be here, but the data you see somewhat here. Okay, but on average, is the line represent the average. Okay, so that is the first thing is X and Y are related linearly. Okay, this is the first thing. Okay, and the goal of this is we want to guess what is A, alpha and beta. Okay, and we'll show you that under this assumption, the A and B in that slide is the best unbiased estimator. Okay, it's unbiased estimator. It's also efficient. So the second assumption we have is X are non-random, which means that X are controlled by ourselves. It's say by experiment or we do it. Okay, X is not random. There's no random variable. It's not random variable. Okay, the only random variable in this is this guy. You can imagine epsilon can be due to, say, random sampling mistake or some factor we can't control. Okay, X is something non-random. Okay, and this is not very important, but we just keep it here because it's classical assumption. Okay, classical assumption, and because they think about this is a experiment idea, so that's why you can control this experiment, right? Because you can decide who get a drug, who get no drug, right? You choose it. It's not someone else choose it. It's not by choice. The third one is saying the error have mean 0. Okay, that means that the thing that you can't observe, which is epsilon, the impact on average is 0. Sometimes it's helping, sometimes it's not helping. So basically, what X is the most important thing to determine Y. Okay, and of course, this is not a truly an assumption here. Why? Because you always has alpha. Okay, if this is not 0, you can always improve the alpha. So this is not something too big assumption. The big assumption comes from this guy. Okay, you're assuming that each observation, the thing you can't observe, represented by the epsilon, have the same variance, regardless of which observation looking at. Okay. And the last one is error terms are uncorrelated each other. Okay, so that means that actually you will see the most important thing you violate in practice are these two assumptions. Okay. First, I will explain why number 4 is important. Okay, very often, if you talk about stock market, this is violate. Why? The price of this minute is related to the price of last minute, right? And we know what we call the momentum, right? If the price have been going in the last minute, the next minute will go up as well, right? It's more likely it can go down, right? So there's some momentum, or we call the lag effect. All right, look at it this way. Now you're very tired. It is likely that the next minute also very tired, right? It's related. If you're very happy now, and then your next minute should be also very happy. It's not completely random, right? So that means that actually this part, very often, that observation of time related is called time series analysis. And this actually by itself is a study. Okay, you can study a whole semester for that. Okay. And secondly, even the I and J are not the same individual, okay, but they are within the same time, they may not be 0. For example, the random effect can be affecting everyone, right? Talking about happiness, right? So how happy you are, okay, explained by how many math you're doing. Okay? The more math you're doing, you're not so happy, or other way around, depends on who you are. But the more time you spend in this class, then you're less happy, right? The beta is negative, right? But it can I run this regression, but this error may not be independent within your class, right? Because of the error term can be like temperature or the weather is affecting everyone at the same time, right? So, and this need not, right? So usually this is called the panel or cross-sectional. Cross-section, okay? They're correlated, okay? So this, or again, panel or cross-section already 2 different classes you can take for the whole semester, okay? And this one, also you can relax because why the error term is same for everyone, the variance, right? And maybe some people are rich, some people are poor, right? And maybe rich people, I don't know, the variance is smaller because they have money, they tend to be very happy, right? But poor people like me, my emotion fluctuate crazy, right? I can be very happy and can be very angry, right? Right? So you may be more, some people are more stable like you, right? Then maybe less problem, right? So that of course this thing, if you want to study further, how to relax all this thing, actually is the study of econometrics. Okay, you study some of them in 2021, and actually people spend this 2011, right? 2021 will be studied this, and then if you go to that department, you can spend 3 years to handle all this thing. Okay, but our life is limited. We love our life, so we don't want to spend too much time on that. If you want, you can go, you can have fun, but okay. So that's what we call the Gauss-Markov theorem. Is under all these classical assumptions, the 4 assumptions we have, with the following. First, the A we have done on average actually give you alpha. The B on average gives you beta. Okay, so that means that if the model, the 4 assumptions satisfy, the thing we do, minimize the vertical distance, the right thing. Okay, remember, minimize vertical distance. Don't say anything about the model. Okay, just a fitting, right? No matter what you're doing, right? But it's saying that if you're willing to make those assumptions, they're good, right? Because when we underestimate things, we want to estimate this, right? We want to discover how X and Y are related, right? So alpha and beta is the thing we care, right? Because once we know alpha and beta, right, we know how X and Y are related, right? This is the fundamental thing we want to know, right? Is it beta positive? Is it beta negative? How big is the beta, right? If you care, right? For example, many practical cases, Y is your income, X education, and actually this is the most important equation in economics. I mean, people run more than several thousand regression for this, right? We want to understand how much you earn if you spend 1 more year in school, right? That's what you do 2 years later. As you graduate, you're very happy, throw up your head, right? And then you figure out, okay, should I take 1 more year in school as a master program, right? That's very often people ask this question. Okay, and the question actually comes from the regression. How big the B beta, right? How big the B is, right? And at least before the LLM, the AI thing, actually invest in yourself is the best. I think the return of education count as the salary increase over your tuition. The return of education is at least 6 to 8%. So I think it's the best even compared to stock market. So the most worth investing, of course, given that you study, okay? It's not paying the money, it's done, right? So suppose you pay the tuition, you study, not lying down, not doing nothing, not copy your homework, right? But that is the case before the ARM and before the AI. I don't know, after AI, it's still worth doing, but maybe even worth doing. Because if you don't know AI, you don't know thing, then you don't have any ability to earn anything, right? So this is the first is unbiased estimator alpha and beta. And second is unbiased, but we can still say more is efficient, right? Because we care about also consistent. We don't want to put it because unbiased is already implied consistency, okay, in general. But this is consistent as well. Okay, as long as the variance is finite, okay, consistent as well. So we also don't want to know the efficiency. And turn out that, okay, this is the most efficient when compared to the case where any other estimator is also linear in Y. Okay, this is a little bit technical. Okay, that's why we call the linear. That's why I call blue. Linear here means that the estimator don't depend on square term or constant term, right? Because when you see the estimator here, I only have Y but not Y squared. not y cubic. Okay, it's based on linear estimator. And this all results saying you that as long as you are focusing on linear estimator, okay, that this formula A and B, okay, is the best. So that means that you can't beat the idea of least square. Okay, so least square is one of the best thing you can do. Now after that, once you're done, right? Now we're saying that this is my model. The line, this A and B coming from the slide before, okay? And what do we learn from this model, right? Because what you do is you're collapsing all this data, X and Y, right, data point, to the line, right? And this Y hat, and this is A, and this is the slope is B, right? So this basically this one. And the meaning is the same, but now the meaning of this model is average. Okay? Because now it's no longer because remember the model is y equal to alpha plus beta x plus epsilon. So you have this guy. Okay, but this guy has mean 0. So that means that when x is here, on average is here, right? But it can be here, here, but on average here. So that's why the y-intercept means when x is 0, on average, y is a, because the average is important. Okay, because now it's a probability model. Okay, and what is b? B is on average. If you increase x by 1, how much on average y increase? Okay, so those are two average here. Okay? Change of x, okay, would change average y on average. So that is a little bit mouthy, all right, mouthful, but that is what it means. So because the line represents average, okay, because it can be any, it can be a lot of point here, right? So improve it on average, y will increase on average, okay. So there is some caveat. I think that is very important. Of course, if you study statistics, they keep asking this question, try to trick you. But I think I'm very kind enough. I'm not going to ask this type of question. But I just put it in the interpretation. So the first one is A, the intercept. Okay, just to make sure that you know that the intercept will only be meaningful if your data have a lot of data around X. So suppose the data is here. You draw a line there, and this A is not very meaningful. If your data is a lot of data is here, very close to it, when you draw it, this A will be meaningful. Okay. Why? Because you extrapolate a lot, right? Because there's no data here, right? You draw it to the intercept, very meaningful. So A in general is not very meaningful. Okay, but we still keep it, but in general, A is not something we care. Okay. The most of the important thing in this regression is actually B, as you would imagine. Okay? Because this how much y will change on average when there's an x change by 1, right? To remind you that there's no causality. Okay, causality will be there if you are the one who change x. Okay, this experiment, if experiment data, yes. If the data is observational, someone collect that for you, okay, you're not controlling the x, then it's not. Okay, and that is just association. And remember, what you're doing is how y change of x, right? But in fact, it's how y minus y bar change of x with x bar, right? Because that is ID. And the next thing is, although the thing may not be linear. Okay, in general, the data can be something like this, the line be like this. Okay, but this is something very important is even though the underlying is not linear, okay, regression remain the best to do the job. Okay, if you focus on linear. So it's a group approximation. Okay, and will be good when it is you have data. Can be bad, you don't have data. Okay, so that has to be a little bit careful. Okay, some caveat. Now let me introduce the idea of residual. Okay, the residual, also the error, is what we have already, right? This formula. Okay, remember this is a random variable, right? And if you recall this equation, this is not a random variable. This is a random variable. Okay, constant plus a random variable. Y is also a random variable. Okay, so let's make sure that understand what the model is. X is not a random variable. Epsilon is a random variable, the error, but that means that Y is also a random variable. Okay, so because this part is fixed, these two are random variable. Okay, now since this is a random variable, okay, so from this is a data, right? This data, the data you observe here, okay, because with the random variable, so this what we call is called residual. Your data, okay, which is like this, right? Suppose this is your data. This is a regression line, and this is called the residual. Okay, maybe I have to be more careful in describing this. Okay, let me draw this. If you believe that the data is coming from yi equal to alpha plus beta xi plus epsilon, so this is alpha, the slope is beta. Okay, what kind of data you observe? You'll be, suppose this is x, I. You may actually observe this number, this number, this number, this number, this number, this number, this number. Okay? Depend on what this realize. If epsilon is more than 0, it will be here. Epsilon less, this is the case where epsilon I more than 0. If you observe this number, will be epsilon I less than 0. Okay, so these are epsilon. Depends on something we can't observe. What's epsilon, right? Something that outside your model, but it's not so important, right? On average, you have 0 impact. Something like temperature, like weather, your DNA, whatever you think you can blame if you make a mistake, right? Maybe location of the star, right? Whatever, your emotion, whatever, right? So this is the thing, okay? And what is error there, okay? Remember, you are doing a sample, right? So that means that maybe your data realized is something like this, right? This is your data, right? If you collect the data, okay, this is data, and you will run a regression, something like this will happen, right? And this line will be yi hat equal to a plus bxi, right? So that would be the idea, okay? And of course, we know the formula, right? B will be summation xi minus x bar yi minus y bar and summation xi minus x bar squared and a equal to y bar minus bx bar, right? So that is the formula. Calculate. Okay. And you don't get the same line, right? But that many line you can get, right? But the Gauss-Markov theorem said, right? If you repeat this regression many times, you get many A, many B's, average of this A will give you alpha, average of this B will give you beta. Okay? But if you only do once, right? Each observation, this is EI. This is EI as well, right? And this is also EI. Of course, this EI is negative, this EI positive, right? This is called the residual. Okay? These small e's are residual. Okay, the residual are actually you calculate from your data. Okay, the errors are actually from notionally in the background. You never observe this. Okay, is that okay? Is that okay? So look at this is a random variable, right? We have said that the variance of this is sigma squared. That is the sigma is controlling how big is the factor outside X in determining Y, right? The random factor. So actually the sigma square actually want to know, right? Because if we know this, it tells us how good is our model, right? If the sigma is big, our model is bad. If sigma is small, our model is great. Okay. So the question now is, once we know A and B, which is a good estimator of alpha and beta, we need a good estimator of sigma, right? Because once we know that, we know how good our regression is. Okay. How to do that is estimate through what we found from the error. Okay. From the regression, you calculate the E, okay, and you calculate sample variance of the based on EI, you get your guess for this guy. Okay. So let me tell you the formula, which is here immediately in the slide. Okay. The formula is just this. This is just variance formula. Okay. You ask why I do that. Shouldn't the variance like this? You ask. Right? Why don't I do that? Right? Should be something like this. Right? The reason being that this guy is 0. Okay. The error on average 0. That's the way how you draw the line. So that's why I don't need to subtract from 0. Okay. And the second question you ask is, okay, hey, come on, why we have -1 become -2? Okay. And as you have seen in the ANOVA case, depend on how many sample mean you guess, you subtract that. In this model, you estimate Y bar and X bar. You subtract 2 things, you estimate 2 things, so you subtract 2. Okay. And that explains that you would guess if you have more than one variable to regress, actually you minus K if a K variable, but this is something that you will do in next semester if you do 2021, but this is the case -2. Okay. And this is guessing the sigma square, right? Is how good your model is, right? Because the bigger the sigma square, then the model is not that good, right? If the sigma is very small, means that the thing that is random, not so important, is not very important. Okay, so that is how S. And very often we don't use this directly, we use the standard deviation, so that's take a square root. So that is called the standard error of estimate. I think this is called the SEM in Excel. Okay, let me show you the calculation and then see if I time to Excel. Okay. So here is the calculation. So make sure that everyone knows what we are doing. Okay. So we have shown this A and B already, right? If you don't are not happy, actually we're here. Okay. So we calculate that. Okay. So what we need to calculate is this y hat. Right? Remember what is this E is your regression. Bunch of point here. So y hat. Okay. The E's are just this. This is a y. It's a hat. So the difference. Okay. You first, how you get this number, right? This number coming from what? Y hat coming from A plus B xi. Oh, there's a typo here. Sorry. Okay, so that's how you get this number. A is 3.9. So how you get the first 4.6 is 3.9 plus 0.0 times 1. So get 4.6. The second one, how you get this number? 3.9 plus 2. Oh, sorry. 0.7 times 2. So on and so forth. Okay. So this to get yi. And you take the difference of these two columns, you get the EI. Okay, sorry for a typo, make sure that you correct that. Okay. And once you have E's, okay, you use the idea that calculate the variance, okay, and just square each term divided by n minus 2, right? N is 5, right? So you get this. This is the guess of sigma square. Remember, sigma square is the variance of the random term, right? It's how good the regression is. It's how big are the factor you can blame, right? If sigma is very big, then you can always claim, not my problem, it's by luck, right? If exam doesn't work very well, right? Right? So you want to study, this is a time, right? You spend on studying, time studying, right? And this is your exam score, right? And if this is big, you can always claim, okay, not my problem. It's a problem of the temperature, problem of luck, or the other guy on the other table is very noisy during the exam, right? Or I didn't sleep very well, right? The sigma is big. You can always blame, yeah, your friend. So because this is 0, so that's why it's a square. Okay, you can check this. The mean is 0. Okay, so let's see if I can quickly show you the one formula is the standard error estimate, SEM. Okay, I forgot the code. Let me check. STEYX. Okay, STEYX will be this and this. So this is should be same as what we have just saw. STEYX. Okay, standard error YX. So this number same as the one we just showed you. Okay, and should be the same as this guy. I don't know why different, but this should be the same. Okay, but there's some rounding error here. Should be wrong. All right. Okay. But anyway, I will see you next week. Enjoy the weekend. Sorry for overrun by 1 minute. I will see you